Hello students, let us work out the last question in this paper. So we have been given a curve with the equation y is equal to 3k divided by x minus 2k, where x is not equal to 2k and k is a positive constant. We need to sketch the graph C, and on the sketch we need to show the coordinates of the point where it crosses the coordinate axis. So even if it is not mentioned to show the coordinates, we have to show the coordinates. The mark scheme would be having marks for the coordinate intercepts. Okay, so if we are having a function y is equal to 1 over x, then this would be the graph of that particular curve. Okay, now if we are actually shifting this graph to the right by k units, this graph would be shifted like this to the right by k units like this. But over here our function is not 1 over x minus k. Our function is y is equal to 3k divided by x minus 2k. So it is being shifted to the right by 2k units. Okay, so I'll draw another graph over here which would be shifted to the right by 2k units. So I'll draw it with green color. So this green color graph is our required graph. So it has been shifted to the right by 2k units. Okay, the other graphs you can neglect. So these two graphs you can just neglect it. Okay, so this is our required graph. I'll just draw it a little bit closer so it will be clear like that. Okay, so there are 2 points that are required. They have told that is, one is the intercept with the x-axis and y-axis. As seen, you can see that this is not going to intercept the x-axis because x-axis acts as the asymptote. Okay, now for the y-axis, to find the intercepts on the y-axis, we need to put x equal to 0. So at x is equal to 0, we have y is equal to 3k divided by 0 minus 2k, or 3k divided by negative 2k, that is equal to negative 3 by 2. So this is the intercept over here, which is negative 3 by 2. Okay, and this is your asymptote. So asymptote, it occurs at x equal to 2k, because when you put x equal to 2k over here, you are going to get divided by 0, which is not possible. So that is actually the asymptote. So this is the point 2k. Okay, so the mark division for this question is, if the shape is correct in the quadrant 1, that means if it is correct over here, this carries 1 mark for the correct shape in quadrant 1, and fully correct shape, it carries another accuracy mark over here. And then if it is if you are showing that it is cutting at negative 3 by 2, this carries 1 independent mark. So this is how the 3 marks are divided over here. Okay, now for the second part, we have been mentioned that there is a line which has the equation x plus y is equal to 12. This line is tangent to the curve. So if for example, this is the line, then it would be a tangent at some particular point at the curve. So this could be the line y x plus y is equal to 12. Okay, so if it is tangent to that particular point, it means that it is going to intersect only at one point, right? So it is going to intersect only at one point, and we can find the point of intersection by just equating the two equations. So the equation of the curve was y is equal to 3k divided by x minus 2k, and the equation of the line or the tangent was x plus y is equal to 12. So to find the intersection point, we can just replace the y value over here. So we have x plus 3k divided by x minus 2k is equal to 12. So you can just multiply by x minus 2k on both sides throughout. So we have 12 times x minus 2k on the right side. Expanded, we have x square minus 2kx plus 3k is equal to 12x minus 24k. I'll bring all the terms to one side, keeping the x terms together, and the other terms are 3k plus 24k, that is equal to 0. So this is minus 2k minus 12, and the constant term is 27k is equal to 0. Now since it is intersecting at one point, we know the discriminant b square minus 4ac will be equal to 0 because only one intersection is there. Okay, so since there is one intersection, the discriminant value is equal to 0 exactly, and this is our b over here. This is our b value. The a value is 1 and the c value is 27k. So now we have b is minus 2k minus 12 the whole square minus 4 times a is 1 and c is 27k is equal to 0. So expanding it, we'll have 4k square. This is minus 2 times negative 2 plus 2 times negative 2k times negative 12 plus 144 minus 108k is equal to 0. So we can expand that middle term again. So we'll be getting 4k square. This is 24 and 48, 48k plus 144 minus 108k is equal to 0. Okay, so now we have we can simplify this portion. 48k minus 100k will be giving minus 60k. So 4k square plus 144 minus 60k is equal to 0. Again, divide the whole thing by 4. So it will be k square plus, actually I can bring the constant term to the other side. So it is k square minus, okay, I'll divide it first of all, right? Plus 36 minus 15k is equal to 0, and k square minus 15k plus 36 is equal to 0. So I think this is the equation that they are asking to solve or show that k square minus 15k plus 36 is equal to 0. Okay, so let us discuss the mark division also. So if you equate it with the correct expression and you get a sort of a equation like this, you will get the method mark, and correct value gives the accuracy mark. And then you apply the b square minus 4ac that is having a dependent mark, and for the correct expression you get over here, you'll get the last one mark. Okay, so that is about part B. Okay, and now in the last part they have mentioned that the line L meets the curve at point P, and the point P is lying below the x-axis. So, and we have to find the coordinate of P. Okay, so the tangent which we assumed was supposed to be below. So the tangent was somewhere over here, that is below the x-axis, would have been here. Okay, so this is the original tangent, or the tangent for the question in part C. Now it is below the x-axis, that is why we had to draw the tangent over here. And this particular curve, this portion of the curve was above the x-axis, but that is not required as of this question, where it is mentioned that the line L meets the point and the point is below the x-axis. So this portion of the curve in quadrant 1 will not come below the x-axis, so that is why we chose the tangent over here. Okay, now at the intersection point we already got an equation for k, and we already solved that particular discriminant thing, and from this we can get two values of k. You can use your calculator to verify it, but you need to show the steps for this one. Okay, either use the x is equal to minus b plus or minus root of b square minus 4ac divided by 2a formula, or you can factorize it to get the expression. So, but you can use your calculator to check it. Okay, so we'll get two values of k. K is either 3 or either 12. So for each value of k, we can get a corresponding x and y value. Based on this relation, we can get it. Okay, so x plus the y value was this much, 3k divided by x minus 2k. So y is equal to 3k divided by x minus 2k, and we know that x plus y is equal to 12, right? And I think we have one more expression simplified, or is that it? Yeah, that is it. Okay, so we can use this expression over here to find out the value of x. Okay, and otherwise there is a simplified expression, I think, over here. This also we can use it. Yeah, this expression also you can use it. Okay, either this is, I think, easier, x square plus x multiplied by that is the same thing as when we expand this one, we'll be getting that x square plus x multiplied by minus 2k minus 12 plus 27k, right, is equal to 0. Okay. So the k value, we have two values. One is 3. So if we are taking k is equal to 3, this is going to be x square, and this is going to be minus 6 minus 12, that is minus 18, plus 81 is equal to 0. When we solve it, we are going to get x minus 9 the whole square is equal to 0, or x is equal to 9. So when we put x equal to 9, we have the other equation as x plus y equal to 12, which is a tangent. The point P is also on the tangent, it's the intersection point, right? So we can plug in the x value here, we'll get y value is equal to 3. So the point is 9 comma 3. We'll need to check it because we need to check whether it is above the x-axis or below the x-axis. So 9 comma 3 is going to be above the x-axis. It seems like this is that particular point. Okay. So this is the point 9 comma 3. So that is not the point that we need. We need the other point that is below the x-axis. So we go for the next value of k, which we got as k is equal to 12. K is equal to 12. So the same thing, we put it in this equation, we put the value of k as 12. So we'll be getting x square plus x multiplied by minus 2 times 12 minus 12 plus 27 times 12 is equal to 0. So that is x square. This is minus 24 minus 12 is minus 36, and 27 times 12 gives plus 324. So when you factorize this, it is going to be x minus 18 the whole square is equal to 0. So x is equal to 18. Okay. So x is equal to 18. So correspondingly, y will be equal to, when you put it in the equation, x plus y is equal to 12, which is the tangent, and the tangent is also a point on the intersection. So you'll get y is equal to minus 6. So the point is 18 comma negative 6. Okay. So let's see, this is below the x-axis, obviously, because the y value is negative. So 18 comma negative 6 is on the it's a point below the y-axis. Okay, the drawing we drew over here, it is an accurate one, that's why we drew it on that side. It was supposed to be like, the point was supposed to be somewhere, if we elongate this curve a little bit to the right, then it would have been the correct sketch. Okay, so we don't know like actually where that particular curve is going to extend, because we are not given a numerical value, it's given in the terms of k only, right? So that is fine, it's understandable that it is below the x-axis. So the particular point was supposed to be something like this. That is what they were expecting. Okay, so that's it. So the correct point is 18 comma negative 6. So we'll go through the mark division also. So the first mark over here is for finding out the different values of k. That is an independent mark. So if you get these two values correct, you will get one independent mark. And the method mark is for finding the different values of x equal to 9 and x equal to 18. If you get it correct, the method and the accuracy mark would be over here, and the last mark would be for selecting this one. If you don't write, or if you choose both the answers and say both are intersecting points, you will not get that particular mark. The correct you have to state that only that particular coordinate of 18 comma minus 6 is there, then only you will get the last mark. Okay, so I hope it is clear. So we have finished the paper from May June 2026 of Pure Math 1. Thank you so much.